Hello, and thank you for watching Hexagon Geospatial e-training. In this module, we'll explore how to use a collection of GeoMedia and GeoMedia 3D commands to create 3D thematic maps. 3D maps are, in simple terms, a natural evolution of traditional thematic maps. 3D thematic maps, however, typically make use of volumetric symbols such as spheres, cubes, and surfaces to represent the underlying value of a subject. 3D thematic mapping is not a new paradigm. However, with rich and diverse GIS datasets readily available via connections, web services, and mashups, you now have easy access to all of your GIS and public GIS data, including attributions. With GeoMedia 3D, you can take advantage of the connectivity within GeoMedia and use the third dimension to create a rich collection of thematic maps. In short, if designed correctly, 3D thematic maps can augment our understanding of spatial phenomena as they distill datasets into easy-to-interpret maps, allow map readers to better understand relationships within seemingly unrelated data, and facilitate the decision-making process, leading to quicker and more confident decisions. Let's open GeoMedia and see how to create a 3D thematic map. Here we have GeoMedia launched, a GeoWorkspace open, and we're in a standard 2D top-down view. The black dots on the screen represent incident locations, and they have been stylized to reflect the number of occurrences at each location. The grid analysis hotspot command has been executed against a density surface representing the points, and the results have been vectorized and displayed in the view using a red transparent fill. This video will expand on the hotspot detection. It will demonstrate how GeoMedia aggregation and labeling can combine with 3D visualization to further investigate our understanding of the incident locations. In order for aggregation to work, we need a collection of polygons in which to aggregate the incidents. Use the legend commands to turn on the display of a collection of square polygons, 500 meters by 500 meters, previously created using grid analysis. On the legend, right-click on Unique Areas and select Display by Scale. These areas will be used to create a thematic map that represents the number of incidents per polygon. In this example, the touch spatial operator is used to spatially determine the total number of incidents that touch each grid polygon. For our example, the aggregation results are already in the legend. To see this in the view, right-click on Aggregation of Areas by Incidents and select Display by Scale. These results have been stylized to display as a thematic map. Double-click on a grid polygon to view the properties. You'll notice that the num of incidents attribute is 5. Do the same to view the properties for another grid polygon, and you'll notice that the attribute changes. The attribute, in this case, has a value of 10. Thematic maps like this are extremely useful because the size of the polygons do not bias the results. In other words, all polygons are the exact same size, and therefore the results do not need to be normalized. The aggregation results look fine because they effectively depict the count using color. However, having the actual count values in context can help the map reader quickly understand the relative counts. Right-click on Incidents Count labels in the legend and select Display by Scale. We can see that the labels now match the count value for each polygon. Now let's see how to use the style properties to stylize legend entries to display in the 3D window. Double-click on the legend entry to open the Properties window. Click the Select Style button next to Base to open the Select Style dialog. Click Properties. When GeoMedia 3D is installed, a new tab called 3D Settings is added to the Style Properties dialog. Click this tab to open it. In this case, the 3D Settings tab is used to extrude each polygon by the attribute num of incidents. Specifically, an expression is used to multiply the num of incidents attribute by 100. This is done so that the resulting extrusions are high enough to be easily seen when viewed in 3D. For our example, ensure the Use Relative Altitude Based On is selected and set to Surface. If needed, place a checkmark next to Use Geometry Z value for altitude and set Use Offset of to -20 meters. Under Boundary Options, use the drop-down to set the Use Extrusion Of to Expression. Create the expression num_of_incidents times 100 and click OK. Click OK to close all the dialogues. Since our example was previously done, I'll click Cancel. Labels can also be stylized for display in a 3D view using the Style Properties dialog. In the legend, double-click on the Incidence Counts Labels entry. With the legend entry properties open, click the Select Style button and open the properties. Click to open the 3D Settings tab. Use the same expression as before, but add +10. With this expression, the count label will hover 10 meters above each of the extruded polygons. Close the dialog boxes. To view the data in 3D, open the 3D tab and activate the Toggle 3D command. Once this button is clicked, the 2D map window is converted to the 3D map window. Notice that each of the grid polygons are extruded to reflect the incident count. Realistic representations of our world are important because they can provide situational awareness. However, as seen by this workflow, additional power lies in coupling the realistic representations of the world with a robust collection of thematic 3D mapping capabilities. Thank you for watching this e-training module from Hexagon Geospatial. For more e-training, please visit hexagongeospatial.com/e-training.